So the other day we were looking at a velocity function. Right, this was going back to Friday's lesson. We had a velocity function. If I asked you to take the derivative of the velocity, what was that actually really equal to? Derivative velocity is acceleration. In the event that you took the absolute value of the velocity, you got absolute value of velocity. Speed. Okay. If I asked where the particle is at rest, the way that you'd figure it out, if the particle is at rest, the velocity has to be equal to 0. All right, what if I asked where the velocity function has a relative maximum? What would you do? Turn to somebody near you. Looking for where the velocity function has a relative maximum, what would you do? Andrew, what do you guys have over there for me? Velocity has a relative max. What are you looking for?
Relative max?
Isn't that what I asked for? If the velocity is a relative max, Andrew, what are you looking for?
Like the acceleration when
I'm totally listening. I'm just trying to take that. If the velocity is a relative max, then the acceleration
goes from positive to negative.
Right. If the velocity has a relative max, velocity has a relative max, the velocity changes from increasing to decreasing, but the acceleration changes positive to negative. What if I wanted to know when the velocity has a point of inflection? Talk to your neighbor about this. What would you do? Velocity has a point of inflection. Velocity has a point of inflection. Lewis, what do you know?
That prime changes from increasing to decreasing or decreasing.
Okay, one more time. If velocity has a point of inflection, the thing that you know?
F prime is
F prime?
V prime.
Right. If velocity has a point of inflection, then the derivative of velocity, which is acceleration, is going to change, increasing to decreasing or decreasing to increasing. Right. You want to think velocity and derivative of velocity. This is a derivative relationship. So kind of like F and F prime or F prime and F double prime. Did we talk at all about taking that antiderivative of velocity?
No.
No. Trust the instincts here. If acceleration is the derivative of velocity, what would velocity be the derivative of?
It's not speed.
It's not speed. The units wouldn't work.
Displacement.
Right? The units here are going to be units like meters per second. Units here are going to be like meters per second squared. So this would have to be meters. The units would have to be meters. So what would you measure in meters? Position. Position, displacement. I'll go with either one of those. So position or displacement. Those are not really equal to each other, but in the world of calculus, I'm going to say they're on the same level. If I take the derivative of position, I get to velocity. If I take the derivative of velocity, I get to acceleration. So let's kind of go one more here. In the world of speed, if I tell you that velocity is positive and acceleration is positive, what's the conclusion about speed? Velocity positive, acceleration is positive. Think about that if you need to. Velocity is positive. Acceleration is positive, meaning your velocity is increasing. So speed is increasing. Speed is increasing. All right, velocity is positive, acceleration is negative. Conclusion about speed?
Decreasing.
Speed should be decreasing. Okay? velocity is negative, acceleration is negative, speed is increasing. And your last option here, velocity is negative and acceleration is positive. So speed is decreasing. Now I want to be really careful here. All of these relationships are about the velocity being positive or negative, the acceleration being positive or negative. We're not having any conversation about what if velocity is 0? Well, if you have no velocity, you're not moving. So your speed?
0.
Your speed is 0 as well. We're not going to make any connections between velocity and acceleration if one of these is equal to 0. All of this together, rotten marker, is basically everything that you need to know if you're in Calculus AB about rectilinear motion, motion in the XY coordinate plane. There's a lot more that's coming, but it is not going to be something we worry about yet. What I want to do is I want to give you guys some time to get some practice with all the derivative relationships, with all these new calculator skills. For those of you that were able to log in, some of you are going to be given the opportunity to drive, which is why we have the cradle. What I want to do is give you guys the next 15 minutes. Go as far as you can on lesson number, whatever the next one is. 32, Connecting Calculus to Physics, Day 2. There's a picture of Supercat there, up at the top. The first time I saw this picture online, my thought was, how did they get the cat to stand up? Honestly, though, that was my thought. How did they get the cat to stand up? I didn't understand how the costume worked. I do now. Okay, 15 minutes. Go as far as you can.
Changes from concave to concave. He's trying to change his concave direction.
Or you weren't? You weren't? Were you?
Andrew, I can no, I need a pencil.
I want to see him just have a good cradle or calculator.
Give me some bullet.
And you were able to log in, right?
Thank you.
Can you take the cradle off? I want to give you a different one.
You can't read.
You can switch it to off. There you go. Okay, and yours works.
No, I mean, right.
Focus on physics. I'm about to check. So for the friends at North Central, you guys might want to pause the video for a little bit, work on the problem, and then fast forward the video about 15 minutes. Hi there. Only David was here.
I'm not sure we got negative out.
E is like this. E negative or E positive. No. This one or this one?
No. So you happen to get a good cradle, and you happen to get a good cradle.
Watch this too late.
So Myra, did it work?
I mean, all we know is
And then it doesn't make sense.
My computer is probably just fine if I agree, but after school.
And like this not happening.
I did it everything. I texted you were texted you were letting me know that was just email. She didn't know. I was just wondering. Question. I was just asking a question. It was too rhetorically.
I was worried because you plug in 0, you actually get
Plugged it into the. I plugged it into the thing and it gave me zero.
no. Oh yeah. No. Oh yeah.
And then you multiply it. That has zero.
Oh yeah. No. I don't know. Even if you plug in 0, you get 1. 1 times 3.
Wait, so it's supposed to have 2 points. 2 x equals 0. Because this is what I got. Yeah. So you want? Yeah, I did my problem. What did you? I did mine. I'm right. But I'm not complaining. But I thought
that's where it starts. Or like where the function.
I mean, that makes sense. Yeah. If you put in 0, you get 1 times 3. Yes, for real.
When you plug in 1, you get
When you put in 0, you get 3
times.
0.
So different.
When you plug in 0, you get almost 0.
So it goes from, oh, it goes like 2 space.
What the?
Isn't
What
it
you
says
doing?
it increasing?
Okay, so you plug in 0, right? So you plug in 0, right?
Yes.
E to the t, that would be 1.
Already.
Like you know that.
We know that. We're not going to know that.
Right.
I don't know, when you plug in 1, you get 0. When you play in 1 minus 4, negative 3 plus 3 is 0.
Yeah.
Oh.
Your mom over there.
So we go like.
I'm not sure what sounds about.
I got you.
No, it goes like. And in case he says something.
One inflection. Wait, mean.
At 2?
Changes from increasing to decreasing. So it'll be
Wait,
like.
why do you have it?
It'll be
No,
like.
no, no. This is the hardest part. I was doing that before I even looked at it.
Okay, yeah, and that's why I said like.
Usually, wait,
Velocity.
How do you do that?
we kind
Like
of
trade? So which is the menu?
I don't know. Yeah.
Menu, one. For G, will we say down at a velocity or a rate of?
A rate of. So it's always the function. Whatever the function is measuring, that's what's increasing or decreasing at a rate.
Yes. So going down, so how is it?
Because with the minimum, we're not
How are
gonna
you?
know if the function
It's a
is
beautiful graph.
changing above.
Don't overthink the graph.
I mean, 3.6.
So fine, I think it's the minimum. So that's. Wait, is that I am the graph that.
Okay. When the velocity is minimum, that doesn't mean constant. It just means
Says minimum must be.
Wait, you can take it as
if I think about constant, I think about like the velocity is horizontal. Like, there's
It
no
says minimum must be smaller than maximum.
Yeah, horizontal. I'd stay away from the word constant, because I think constant, I think like not changing over an interval. Right, it's horizontal. You're right that the acceleration is gonna be 0 at that point, because the derivative, the velocity has a horizontal rate. Determine the acceleration of the cat when the velocity is So at this time, when the velocity is minimum, the acceleration has to be 0, because
Yeah.
You do
perfect. Yep.
okay, 1 and negative 2.
And Giselle, have you figured out yet that all the work you're doing on your calculator is getting displayed up there? Which is one of the reasons I wanted to use the navigator system, so that I could turn you on. No, you're fine. You don't have to talk, you just have to type and do the math. Keep going.
You got
Can you
the
move the clock that's up there? You have it.
How'd you find it?
Why does it not do?
You know that?
Keep going. You guys are not making nearly enough progress on this.
You do B prime. B prime. I did. Look, menu. 6.
What did you get?
Yeah.
You from?
No, but like, what is this?
We have a little
I mean, you can just find it.
So I went back to Zoom Standard, and what was it you were trying to do for X min, X max? Okay, I would definitely would not do negative 200 if you're given a domain restriction of 0 to 3.5. Negative 200. Okay, I wonder if what
For
I took 1.5.
DOT has to put us in zero.
Yeah.
I was right.
Cat is decreasing. How do I get them all? Right? Yeah. Okay.
Latest and big.
Or negative 10. So then, wait, what's the messenger? How does the velocity represent
Minimum velocity.
Yeah.
If you're gonna graph EDX,
No, just minimum.
That's what it is.
not
Oh,
the
yeah.
Yeah, that's it.
Never that one.
If the cats are reaching What if the interval is like just 3 flat?
Yep.
Oh, delay.
Oh, no.
Okay.
No, no, no. Sorry.
Because you have to continue from physics to that. The delay.
All right, friends, we're gonna take the pressure off of my friend Giselle here. And let's check to make sure that everything's going okay. Why does it do? All the technology is deciding to fight me today. That's okay, Hulk smash. All right, so if all goes well, yeah, can't see a darn thing. And Stephen, if you could do your thing. All right, part A, velocity at 1.5 is negative 3.361. On one of the homework assignments you guys did last week, a lot of y'all were reporting decimal answers accurate to 2 places after the decimal. It has to be 3. And I think what happened is we hadn't used the calculator in such a long time that your calculator reset. It has to be 3 places after the decimal all the time. So negative 3.361 at time t equals 1.5 seconds. Her velocity is negative 3.361 meters per second, which means that her height is decreasing. Velocity derivative at 1.5, negative 7.843. At time t equals 1.5 seconds, her velocity is decreasing at a rate of 7.843 meters per second squared. Everybody nice and easy? So what's the conclusion about speed? I know that's not one of the questions I asked here. Speed at t equals 1.5, increasing or decreasing? Speed at t equals 1.5, increasing or decreasing?
Increasing.
Look at those values again. The velocity at 1.5 is negative, the acceleration at 1.5 is negative. The only correct conclusion is speed is increasing at t equals 1.5 because velocity and acceleration are both negative. All right, good. Determine the acceleration of the cat when the velocity is the minimum. You have a minimum over here at 2.414. The acceleration, which just means the derivative, 0. Good. All right, D, on what interval is the cat's height decreasing and acceleration positive? Think about this for a second. Height is decreasing. What we see in front of us is a velocity graph. If height is decreasing, velocity is careful. Height, the height of the cat, decreases. So velocity?
Oh, listen.
Velocity is negative. If the height is decreasing, I want to go back. I want to go back to these relationships over here. If height or position is decreasing, then the derivative, which is velocity, must be negative. Lewis.
Oh, and it has to be.
So what?
And they have to be.
Then it has to be
No,
increasing?
and it has to be like negative x.
Right now, all I care about is velocity is negative. If height is decreasing, velocity is negative. That's the thing. But then there's another part, right? I then go on to ask for the acceleration to be positive. If acceleration is positive, then velocity has to be increasing. So I need places on the graph where velocity is negative and increasing at the same time. The only place where velocity is negative and increasing is going to be from this, what, 6.241? Oh no, 2.414 to t equals 3. In terms of reading the graph, is everybody okay? We get this under control? Good. All right, so let's push a little bit. I want to talk about part E, and then I want to talk about part H. E and H. Part E, this is definitely a push for the calculus BC friends. This is not something I would necessarily worry about in AB. Using your calculator, determine the intervals on which the cat's height is increasing. Justify your answer. So, number one, use the calculator. And then we're going to put the calculator away. I want to know where the cat's height is increasing. So you've got the graph of the velocity in front of you. What's the thing that we would look for? If the height is increasing, Palamon, what are you looking for in terms of velocity? If the height is increasing, then that means velocity must be positive.
Yes.
Because velocity is derivative of the height. So I'm going to look at my graph, and I bet you guys can tell me pretty quickly from the graph where the velocity is positive. Myra, do you know where the velocity is positive? From 0 to 1. Now, do I include the 0?
Yes.
Look at the graph. Is the velocity positive at 0? Yeah. How about 1? No. And from 0 to 1, anywhere else?
From 3.
3.
To 3.5.
From 3 to 3.5? Easy peasy with the graph? Now let's do it without the graph. Okay. So without the graph, here's what we need to do. We need to get really clever with this idea that the velocity is positive. If your velocity, which is e to the t times t squared minus 4t plus 3, is going to be positive, what I want to do is I want to approach this like a number line test kind of problem. And if you remember what we do with the number line test, the first move?
Plug your number.
No. Your first move is actually set this whole equation equal to 0. So you can solve that equation. I've got e to the t times all this stuff over here. Well, t squared minus 4t plus 3, I think you guys can factor that pretty quickly.
-3, -1.
Should be not -3, -1, but like, give me a binomial and a binomial.
X minus 3, X minus 2.
Oh my god, how about the right variable?
T minus 3.
T minus 3 and T minus 1. North Central, it's Steven that you're laughing at right now. E to the T times T minus 3 times T minus 1 equals 0. The solutions. T equals
3.
3.
T equals 1.
T equals 1. How about this guy? Right? You'd want to think, where is e to the t equal to 0? Where is e to the t equal to 0?
Oh, at 0. I mean,
Think about the graph.
Never.
Where is e to the t equals 0? The graph of e to the x is increasing from left to right. with a horizontal asymptote at y equals 0. So where's e to the t equals 0?
Never, does not agree.
Never. This guy here is never equal to 0. So I'm going to go to my number line. And one of the other things I saw in the homework, we're not labeling the number line enough. Tell me what function you're talking about. I know I've got t equals 1. I know I've got t equals 3. And we need to test values in each interval. So for example, I pick something to the left of 1, like 0. Pick something easy. Plug in 0. Evaluate the factored form at 0. E to the 0?
3.
E to the 0 is 1.
Literally.
0 minus 3, negative 3. 0 minus 1, negative 1. 1 times negative 3 times negative 1. Positive. All I care about is the positive. Between 1 and 3?
2.
2. 2. E squared. I don't know what e squared is,
Positive.
but I know it's positive. 2 minus 3, negative. 2 minus 1, positive. Conclusion,
Negative.
negative in there. Pick something bigger than 3, like 4. E to the 4th, positive. 4 minus 3, 4 minus 1, positive. Now here's something that I want to make sure we get ourselves in the habit of. The easy mistake to make is to have 4 black markers in your pocket and think that that's going to be helpful. Okay? The easy mistake is to say, oh, you want to know when the height's increasing, so velocity is positive. So the velocity is positive from negative infinity to 1 and from 3 to infinity. What's wrong with that? Let's get some hands on this. What's wrong with saying from negative infinity to 1 and from 3 to infinity? Only one person sees a mistake there. Andrew, you see that? Carmen, you see that? Andrew, what's the mistake?
It's just asking from the intervals from 0 to 3.5.
You're only looking on a restricted domain from 0 to 3.5. Here's my advice on your number line. Make that clear. If you're only going to go from 0 to 3.5 and you're not interested outside of that, like I would physically block that off on my number line so I know only put answers between 0 and 3.5. Lewis.
So you wouldn't plug in 4?
4, good idea. Probably not the best choice, but here's the thing. This is a number line for v of t, which is like the entire function, right? All I needed to know was pick something to the right of 3. So plugging in 4 to test the value is okay. Including 4 as part of my answer, not okay, because I'm only going to use this function from 0 to 3.5. Are all the friends okay? I wanted to go with a function that was going to be a little bit trickier to factor and do the number line test with. I also wanted to get us into a conversation about your number line test. We've got that, so let's wrap this up. H of t is increasing when v of t is positive. When's v of t positive? From 0 to 1 and from 3 to 3.5. Brackets on the 0 because velocity is positive there. Brackets on the 3.5 because velocity is positive there. And all the friends are okay? Yeah. All right, couple of quick announcements that I meant to do at the beginning when we were having our TI Inspire issues. Tomorrow night there is going to be a take-home quiz. The take-home quiz is going to cover all the physics stuff that we're doing right now, plus antiderivatives. I'll give it to you tomorrow. It's due Wednesday. Wednesday, we'll grade it as soon as you walk in, because on Wednesday I'm going to give you the take-home test that's due Thursday. This is a little bit different from what is in like your student packet, but the test is going to be given to you on Wednesday. It's early release, due on Thursday. By doing it that way, then I get to include that unit test in this 6 weeks, which is going to help some folks out a little bit. All right. Tonight's homework is a bunch of multiple choice questions. So make sure you get those copied down. All right, and it's the homework. It's in the problem set packet. It should say assignment for lesson 28, maybe? No, wait a second. No, 32. Assignment for lesson 32.
Was it harder than less than 32 or more like 3.1?
Okay, so it's problems 1, 2, 4, 5, 7, 8, 9, 11, 14, 16, 19, and 21. 1, 2, 4, 5, 7, 8, 9, 11, 14, 16, 19, and 21.
You should write these down.
All right. Last one that we're gonna do. Last problem. We're gonna go over to part J. And now that I'm thinking about this, I wish I had done this a little bit differently. All right.
Is that 8 or 19 or 18?
What are we asking about?
16.
14, 16, 19. Yep, 14, 16, 19, 21. All right. All the friends are okay? All right, so we're gonna do part J, which is asking you to sketch the graph of the cat's height. We're gonna assume that the cat starts on the ground. Now, here's the weird thing. I meant to actually include the sketch of the graph, so I'm just gonna transfer that sketch down. Maybe you wanna do that as well. I'm gonna use this as the graph for part J. If you just wanna copy your sketch down to that box for part J. On the x-axis, I'm gonna put time. On the y-axis, I've got height. This graph that currently exists here represents your velocity graph. I want to create a graph of the height. Things that we know for sure. We know that the cat starts on the ground, so at time t equals 0, the height's going to be equal to 0. Now, what I want to do, based on what we know about velocity, what can we say about the height? For example, on this interval here, from 0 until, I think this is at what, t equals 1? Yeah. What do we know about velocity? For 0 less than t less than 1, I know velocity is positive. I can see that. And I can tell you that velocity is also what, decreasing. So if I want some statements about height, what's the height doing?
Increase.
Velocity is positive, height is increasing. If velocity is decreasing, then height is
Negative.
velocity is decreasing. Acceleration would be negative. I'm going up. Concave down. Nice. So what I need on the interval 0, 1, starting here, I need my height to increase, concave down. Increase, concave down looks something like that. Another interval that I'm interested in, we'll just call this like t equals a. On the interval 1 less than t less than a, we know height is, what is it? Height's negative, and height is decreasing. Oh, sorry. Ooh, it's Monday. Just real quick, velocity is negative and velocity is decreasing. So height must be, if velocity is negative, height is decreasing. If velocity is decreasing, height is concave down. So draw decreasing concave down from 1 until I hit A. On this next interval from A to 3, height is negative and increasing. So that means I should be, my height should be what, decreasing, but concave up. And on this last interval, velocity is positive and increasing, height is increasing and concave up. And that would be a quick sketch of height. We'll continue playing around with this tomorrow, so don't sweat it too terribly much. I know we were going fast there. Tonight's homework is the multiple choice. See you tomorrow. Hey, Mr. Link.